welcome everybody to the Applied Imperative podcast once more. This episode, we have a great guest with us. I'm excited to introduce him here. His name is David Meyer, and he is a business development manager for an industry sector at Siemens Digital Industry Software called Sustainable Energy Solutions. So David is looking at all sorts of different areas of new technology and new energy sources coming to market. And I'm interested to get into that with him. We're going to talk maybe a little bit about hydrogen, about renewable natural gas, maybe sustainable aviation fuels, some of those sorts of things. So really interested to get into this with David. So David, welcome to the podcast.
Thanks, Dale. Great to be with you.
Yeah, great. Really appreciate you taking the time. Okay, so I was thinking about this coming into it. I've had a little bit of experience with hydrogen, and I'd probably talk about that a little bit later as we go through. But I wanted to get sort of your sense around what you're seeing around the momentum behind, new energy sources. We are always reading nowadays about this voracious demand for energy to fuel data centers, to, help with the AI revolution. And, I think there's a couple of tailwinds here, right? You've got that pushing things in the direction. You've got the whole decarbonization effort, which is obviously very important as well. How are you seeing that when you're talking to customers? Is there a real sense of urgency? Is everybody like, I need this now, or are they sort of scaling more methodically? Like, how are you sensing that from the market?
Sure. There's definitely an appetite, and a lot of it is driven by the realization that we need to decarbonize along with the ever-increasing demand for energy. And so what we're seeing, I'd say, in the hydrogen sector is a real interest to expand hydrogen into power generation. We see a lot of utility companies like Southern Company and others who are putting a lot of effort into looking at hydrogen powered turbines for electricity generation. And we see a lot of activity around green hydrogen, either for transportation or for use in green ammonia for decarbonizing fertilizer supplies for the world's crops. And beyond that, we're also seeing a great interest from the airlines in sustainable aviation fuel and other types of transportation fuels. So really a high level of interest out there, both from a climate change standpoint and just being able to increase our energy portfolio.
Mm-hmm. Great. Yeah. Yeah. Lots of tailwinds, like we said, and I'm sure you're getting a lot of interest and a lot of demand on your time. So given that strong momentum, the sense of urgency, whether it's business related or environmentally related, what are you seeing with the most innovative companies that you're dealing with? How are they leveraging the tool set, leveraging processes, all the good stuff that we do with Siemens software? How are you seeing the best of the best kind of leverage that and bring in the digital engineering, digital manufacturing tool set?
Well, what we're seeing a high level of interest in, among other things, is simulation and
Mhm.
being able to simulate these new processes because in cases like hydrogen, we've been producing hydrogen from fossil fuels for decades. But when you look at green hydrogen or some of these new technologies, the science is still evolving. And it's not only getting the science of an electrolyzer, which splits water into hydrogen and oxygen, but it's saying, how do I optimize that process so that I can finally get green hydrogen to a price point that's competitive with either gray or blue hydrogen, gray being straight fossil fuel, blue being hydrogen that has the carbon dioxide sequestered afterwards. And so the simulation on the process side is very important to these companies. It also helps them prove their viability to their investors so they can help get the funding they need. And then as you go further in the process, using technology to model and simulate automation strategies and optimize plant performance. So what we're really seeing is a lot of software-driven tools that enable these producers and these developers to say, hey, this is a design that's going to work, and this is a design that we can scale much faster.
Mhm. Great. Yeah, thanks. I didn't quite kind of make that link, I guess, between simulation and then, investors and sort of selling the whole concept. So that's good to know that that's being used there. Interesting stuff. So just drilling down into hydrogen a little bit more, what do you see like holistically across that industry are the sort of unique, maybe challenges or opportunities? Like I know when I was dealing with a hydrogen aerospace program, the whole supply chain of getting clean hydrogen to the right locations, the right frequency and cadence was a concern. Are you seeing that? And you seeing other challenges and opportunities with hydrogen?
Yeah, definitely the supply side is important. There are not really any existing hydrogen pipelines or the way there is for natural gas or petroleum. Hydrogen, in order to be really transported well, often needs to be frozen to temperatures, and there's a lot of problems with what they call boil off, meaning they gets a little too warm and it leaks out and you lose, and we've heard producers in some of their studies suggest they might lose up to 20% of their product just from boil off. So there's definitely a lot of problems in the logistical handling of hydrogen. In addition to that, there's a lot of challenges that are shared by a lot of greenfield and brownfield scale-up industries. You've already touched on, scaling quickly. That's a big challenge. Leveraging data, AI is a huge topic that I'm sure you talk about regularly on your podcasts. And being able to leverage the data is really important. An example in green hydrogen that we're looking at and that customers are starting to use, for example, is weather data, because a lot of green hydrogen is driven by either sunshine or wind to produce the electricity that runs the electrolyzers. Well, if you look at forecasting in a given area like Southern California, Arizona, you can get some pretty good weather data on what the wind and solar, energy looks like over the course of the year. And by using that information, you can analyze, okay, what's my best energy balance for this time of year? Combine that with your cost data. What does it cost to produce electricity from solar? What does it cost to produce electricity from wind? And you can start to use that data to really efficiently run your plan. And so that data piece is important. And designing your new systems with that in mind becomes really important. And in another area that's really cropped up, I would say, at least on my radar in the last 4 or 5 years, is the workforce readiness piece. And the fact that there are fewer people in the workforce and there are a lot of knowledge that's retiring from the workforce. And we've seen studies that show the knowledge base in manufacturing, the average knowledge base has gone from 7 to 9 years to down to, in some cases, less than a year. And so being able to transfer that knowledge, bring workers up to speed faster is another area that's really important to these projects.
Mm. Yeah, that's great. So a challenge with making sure that the information and the knowledge, institutional learning, and et cetera, is retained. Opportunities in leveraging data to understand the whole mix of energy supply and optimizing the plant. That's fascinating. Actually, I was reading recently about a satellite company that's offering a service where they can literally predict where it's going to start raining to very high accuracy, like within minutes, because they're penetrating through the clouds and then watching. I don't know how they do it, but whether they're watching the temperature of the ground change or something as the rain is falling, I don't know how they do it, but leveraging that data to a very high fidelity is getting to be very, very powerful these days. Just keeping my aerospace hat on a little bit, I'll just take you on a little journey that I had with my own personal experience with hydrogen. In my previous role, we were working on an aerospace kind of technology demonstration program to show that an aircraft could fly at least partially powered by hydrogen. And I got to learn a lot about hydrogen on that program. I was pretty naive a bit about it, I guess, to begin with. And I think, a few takeaways for me: hydrogen always wants to escape because it's very, very small. And you mentioned that earlier. And it always wants to go up. If it's gaseous hydrogen, it wants to float. It's lighter than air. So we had a lot of discussion, especially in an aerospace setting. How are we going to understand where it's at all times? How are we going to sense it? How are we going to make sure that the systems can either purge it if we have, too much of a leak and the concentration is increasing? What are the safe limits? And it kind of gets to this point where it's like this U-shaped curve where the ignition energy is very, very high to begin with. And then it becomes very, very, very low, and it can ignite very easily, and then it comes kind of high again. So just understanding the concentration levels was very easy, the leakage rates. And then when it burns, how does it actually burn? Is it, completely explosive, or all those sorts of elements? So that was very interesting for me to learn in an aerospace setting. And the good news was, all of these issues, let's say, were very solvable. And then you think about most aircraft today, runoff of kerosene and, volatile, compounds like that anyway. So there's definitely ways, and I think there's a lot of innovators thinking about how we can take hydrogen into a discrete aerospace setting, which was very encouraging and very interesting for me to be involved with. So, okay, just finishing off, I guess, the aerospace piece, and you've kind of mentioned it a little bit already. I think, transporting hydrogen in liquid form definitely comes with that challenge around temperature, stability, packaging, containerizing, getting the right flow to the right places at the right time. Is it green? Is it not green? Especially if you want to decarbonize aerospace and you want to do that with green hydrogen. So, is there anything else you can think of in terms of if the aerospace industry per se wanted to move in a hydrogen direction, given that it's distributed, it's all over the country, all over the world, there's airfields, airports. Anything else that you think of there in terms of how that infrastructure needs to grow up and mature up?
Yeah, and thanks for sharing your story. And as you know, and you alluded to, the aerospace industry has used hydrogen for decades. NASA has used hydrogen to power rockets and has done so, very successfully. And so hydrogen in air flight is not new per se. It would be new in aircraft. And I think, again, the key is the transportation storage piece, the temperature piece. And so if you look at companies like Airbus, they've done some fairly extensive studies on this, and they've decided that the route to go is fuel cells, which would allow for the generation of electricity for a turboprop or some kind of engine directly from hydrogen that's a little easier to store, a little bit more compartmentalized. And so I think what you'll see is, like in all these emerging technologies, the smart scientists, the smart engineers are going to look at this very carefully and figure out the best technologies to apply to those circumstances. Aircraft flight is kind of easy because it's pretty clear to everyone that batteries are just too heavy and take up too much cargo capacity. And so you're going to have to go with some kind of fuel source. And I think hydrogen and hydrogen fuel cells are really interesting, not only for aircraft, but over the road trucking and many other transportation industries.
Yeah. Yeah, that's definitely another area I learned about on that program. Hydrogen fuel cells, how they work, the proton exchange membrane, right, where you feed in the hydrogen with compressed, humidified air. You humidify it so you don't dry out the fuel cell. Then it strips off the electrons. You get, DC voltage out that you might need to convert. It was a fascinating process. The controls and the logic and all the elements around that as well. There's definitely a lot happening in that space. So fascinating time to be watching that.
I
Okay,
agree.
let's pivot slightly here then. So sustainable aviation fuels as well. That's been a big buzzword as well for a long time. What do you see there? You're dealing with people that are looking at that as well. Are there opportunities and challenges there as well?
Yeah, for sure. And what's really interesting about SAF, as it's commonly known, is the airlines really want it. I mean, there's a lot of demand out there, and you'll see all the major airlines testing it, uh, signing offtake agreements as the supply is available. And I think, and so unlike the ethanol market, which became an additive to gasoline years ago, and I was very involved in the build out of the corn ethanol plants in the Midwest, there wasn't really demand there, and the oil companies fought it. In the case of SAF, the airlines want it. It's just a matter of being able to make it and being able to make it at the right price point. And so, from my perspective, that market opportunity should drive a lot of development in that area. And I hope to see that accelerate soon. There's a lot of companies working on it. Another interesting thing is one of the best paths technology-wise and process-wise to sustainable aviation fuel is ethanol as a feedstock. And there's many well-established companies who have developed what they call a ETJ or ATJ alcohol, which is really ethanol alcohol to jet processes that could easily take the ethanol we produce today and turn it into sustainable aviation fuel. But again, it's a matter of getting those price points right and getting enough production to do it. But I definitely see that as an area that we should see growth over the coming decades and hopefully very quickly.
Yeah, for sure. It's going to be fascinating to see all of these technologies coming to the fore. And like you say, whether it's SAF and hydrogen, battery electric for very small aircraft maybe is going to be really interesting. Okay. something I don't know much about, so I'm hoping you can educate me here. RNG, renewable natural gas. I did a little bit of research before we came into this, just learning off of Google what it is, how it works. But can you share some observations there in that industry, please?
Sure, absolutely. So just to level set, renewable natural gas is most typically produced by taking biogas from anaerobic digestion, let's say of municipal waste or food waste. I've had customers use like potato waste from potato processing plants to create biogas. And then you essentially clean it up, purify it, and you come to a methane that's a direct replacement for the natural gas we all know and have used for years. And so really the advantage is number one, all the transportation infrastructure that we just talked about does not exist for hydrogen, already exists for natural gas. And you have the opportunity to decarbonize, let's say, waste and other things by putting it into this type of product. So I think it's a really interesting market. We have companies looking at it for forest waste. I mean, even you look at what happened in California this summer with the wildfires and the need to clean up all that underbrush. There's a lot of companies looking at that and saying, "Hey, that's an opportunity to use bio waste to help our energy transition." And so I think it's a real interesting opportunity. The supply chain of the waste and how that is converted along with building out the plants needs to continue to evolve. But I think we will see more and more of these RNG plants pop up in logical locations, whether they be at large landfills in municipal areas or forest waste collection sites or what have you. But it's another interesting area that I think we'll see evolve over the coming, let's say, 5 to 10 years.
Yeah, that's really interesting. Actually, when you think about it, we're using product that just would be wasting away. Now we're actually able to capture something meaningful out of it and decarbonize, as you mentioned. So yeah, really interesting space to watch as well. Okay, great. Um, Carbon capture. I hear a lot about carbon capture, carbon credits, and then also carbon capture as well as we're producing maybe electricity from dirty sources. How do we capture that? Remove it from the environment, etc. What do you see there?
Yeah, there's a few aspects. For example, right now, some of the carbon credits that exist through 45Q and some other legislation, um, in many cases, make it more lucrative to simply capture the carbon and hold it. Um, in other cases, there are any number of companies that are looking at new ways to utilize CO2 as a feedstock for solids like concrete and plastics replacement. There's development by companies around CO2 driven turbines for electricity generation. And as I go to these conferences and do research, I'm amazed at the different diversity of companies and examples of using CO2 for other products and the range of scale from small bolt-on units for an ethanol or other, relatively small CO2 producer that simply wants to decarbonize to much larger scale power generation and those sorts of things. So I think the whole carbon capture CO2 dynamic is really interesting. I think we're going to see a lot of great development there and a lot of opportunity in like the specialty material, specialty chemical space coming with CO2 as a feedstock, which obviously would be, at least in my mind, preferable to just putting it in the ground or putting it in a tank and letting it sit there, right? Let's use it for something productive. So I think that's really interesting. The other part of carbon capture is the simple sequestration piece. And there are also, as you're probably aware, several companies working on what they call direct air capture, where they have some sort of media that simply draws carbon out of the air and sequesters it, and then potentially they renew the material and sequester it as a gas, or they use it as a feedstock or what have you. And there's many different technologies. And the nice thing about direct air capture is it can be applied anywhere. You could put it in Wyoming, you could put it in California, you could put it in the desert, wherever you have a need. And there's interest from corporations in investing in these companies because they get carbon credits for the decarbonization these companies are achieving with their facilities. And so there's a whole dynamic of economics here around companies, even like Siemens, investing in direct air capture companies, not only because they believe in the decarbonization piece, but because they can take those carbon credits, and use them towards their decarbonization goals.
A nice kind of circular benefit there. So it's interesting. You mentioned concrete as well. I was watching, there's a show on Netflix with Bill Gates, What Comes Next or something, I think it's called. And it mentioned in that the concrete industry is a huge, potential source of pollution and carbon and things like that. So yeah, that would be an interesting area to watch for sure. Okay. Thanks so much for all those very unique sort of industry perspectives, giving us a bit of a sense of what's happening in all of them. And as an ecosystem, it really sounds like there's a lot of good stuff going on in the background. How can we now tie that to, the getting the speed to scale, maximize, getting the workforces ready, as you mentioned, leveraging data to the maximum, and the themes that we often talk about, right? Digital twins, digital threads, the industrial metaverse as that's coming on. I'm sure you're going to say that all of these things will help these companies achieve their goals quicker, cheaper, and more accurately with the simulation piece. I don't want to put words in your mouth. I assume that's what you say, but is there anything else you think about as you look at the tool set that we can bring to it?
Yeah, I really think, the key for if you're developing these kind of projects is, talk to your suppliers like Applied CAX, like Siemens early in the process and understand the tools, especially early on in the software that they can bring to bear and do that ROI analysis, because I think you'll find that those tools will give you benefits not only in cost but in speed, and all of those are going to help you in the long run achieve your goals. And so whether it's taking software that simulates and optimizes your process, optimizes your design, reduces the number of skilled workers you need who aren't available to achieve the design, or set you up to leverage your data for AI by simply providing you a good foundation in a standardized architecture and tools like edge computing that give you access to, let's say, hydrogen fueling stations and allow you to take data from different stations and even make that transparent to your users so they see what's available and they can look and say, oh, this fueling station's down, I better go somewhere else. And so all these technologies that are going to help you succeed as a business, I think it's just really important that you talk to your suppliers up front and understand what's out there, what's available, what are the advantages of the digital twin. Look at the references they have, because even though those references might not be in hydrogen or sustainable aviation fuel, they've got them with big chemical, big oil and gas, companies that are doing the same things, just with slightly different products.
Yeah, that's a great point. I was actually talking to another customer yesterday about model-based systems engineering as well, MBSE, and we've done a few podcast episodes on that. And I was making similar points to you. The earlier you talk about it, the earlier you think about this holistically across the company, the earlier you can think about your processes and the tools that come into that, the more potential savings you're going to have, and the elimination or certainly reduction of late discovery as well, which, as we know, is always very costly. So, understanding as early as you can, leveraging these tools, and like you said, look at other data points. There are similar adjacent industries maybe where they've done this, and you can use that to help sort of justify the business case. I mean, to that point, are there any sort of tangible data points that you've seen? I know that, in my research on MBSE, for example, I was finding some companies claiming 55% faster, product development and, 30% reductions when you use model-based definition in the detailed design phase and things like that. Are there any tangible data points you can lead us to?
Sure, there's several. I can give you a couple of examples. One is in the simulation department around simulation of automation. We've seen, for example, a big industrial chemical site in the Midwest. They saved over 30% in their commissioning time to bring a system that was over 4,000 IO online. And that meant weeks of time that they saved wringing out their control schemes. Because normally in a build out of a plant like that, you'd wait for mechanical completion, then you test all your automation code around your PLCs and your process automation system, and you find errors along the way, not just errors in wiring, but errors in coding and mistakes. And when you create a digital twin and you can simulate all those coding and all those interactions, you're going to wring out a lot of those errors. And these real world examples, and we've heard from other customers, it's somewhere to 20 to 50% of the time they save in commissioning. And that's real money, real time, saved not only in resources, but faster to making real product and getting cash flow from your operations. Another example is on this data side, the whole interaction between IT and OT. Classically, those worlds have been very separated with their own kind of fiefdoms, and one person runs IT, one person runs OT. And to be honest, their visions don't always agree, not because they're bad people, just because they have different goals. And so what some of the technologies your company and mine promote can help those worlds more easily come together, create an infrastructure and a foundation of data around an integrated IT/OT solution that reduces the design time. And we've seen, again, design times reduced by, let's say, 20 to 30% on the technology side, IT/OT design. And you're left with a much better system that accomplishes the goals of both, let's say, IT or OT organizations. And so those are two examples, and I'm sure there's several others I could come up with.
That's great. No, those are really powerful. Thanks. And oftentimes it's giving those tangible data points that people can hang on to. And when we talk about those sorts of savings, that's big, right? It's not just the time saving. You've got all the labor that you're carrying during that period of time. Maybe you're getting your product to market sooner, or you're capturing credits or saving carbon, whatever it is. So there's like all these sort of ancillary additional benefits, which is great. Okay. I like to think about the future a lot. I'm super fascinated with everything that's going on with AI and all the development with robotics and energy and everything else. And maybe this is a bit of a long time frame, but I'm going to challenge you. Project yourself 20 years into the future. You're intimately involved with all of this. You're seeing the innovation. You're seeing the technologists trying to bring products to market. What do you think the state of the energy industry looks like in 20 years? Are we much more decarbonized? I assume we would be, but what do you think it would look like holistically?
Yeah, it'll be significant. There's some interesting data on the DOE has done studying this, and what seems to be clear is renewables are going to grow, and I've seen projection, out to, like, let's say 2050. So let's call it 25 years, where renewables, which currently account for maybe 8% of our energy production consumption, grow to around 30%. So let's say a significant increase. Fossil fuel use declines, but not as fast as a lot of people would like. Their projections have it declining from currently about 80 to 85% down to around 2/3. So let's say 60 to 65%. But when you think about it, it's still progress, and it still is a great market opportunity in the energy sector. And it also, to me, it mirrors what we've seen in other places. As I mentioned earlier, I was really involved in the build out of corn ethanol. Well, corn ethanol went from zero to about, I think we're around 15 to 18 billion gallons now that, they might only be 8 or 10% of our, fuel system, but that's still 8 or 10% that's made
Right.
from renewables, right? It's
Yeah.
still something that people notice. And so I think what we're going to see is, not one technology. It's not going to be only hydrogen. It's not going to be only renewable natural gas. It's not only going to be SAF. It's going to be a combination of all these things that ultimately get us over the finish line. It's probably going to happen slower than a lot of people would like it to happen. But as long as we're headed in the direction, that's a good thing, and it's a good opportunity. And so I think we just have to bear in mind that it's a combination of technology, it's a combination of industries that are going to get us there. Let's continue to, sponsor that innovation. Let's continue to look for those solutions, and we will get there. And I think the past and what's happened proves the fact that we can get there. It's just going to take time, and it may be not us, it may be our grandchildren that see it happen, but that's okay. It's still progress.
Yeah, absolutely. And some of these technologies are difficult to implement, or they're complex. They take a while to design the systems. And some of the things that we're seeing, let's say specifically within NX and Teamcenter and things, with co-pilots coming in, helping accelerate that design cycle. And again, to your point, bringing products to market faster. So we're going to see a big mix, like you said, of multiple different technologies combining. In general, renewables going up, fossil fuels going down, and maybe as the fossil fuel component to it, some of that carbon that's being produced being captured, as we talked about as well, right? So It's going to be a very interesting, bright, and dynamic future. David, thanks for taking us through that and sharing, some of your experiences and relevant data points. Definitely resonated with what you said around the simulation component and the use of big data, and also just in general, anything you can do to shave the time of development off just leads to this sort of compounding flywheel effect in terms of saving costs and capturing revenue and all that good stuff in general. So as we wrap up here, are there any other sort of closing thoughts you have around what you're looking at and how Siemens Digital Industries software can help?
Sure. I guess one other area I would really encourage is collaboration. It's really important, especially in these large complex projects. You've got a developer, you've got an owner operator, you've got an EPC, you've got numerous OEMs, you've got suppliers like our companies, and the communication there and all getting on the same page and using the software tools that we have to collaborate and drive common designs, using tools where multiple people can engineer at the same time and collaborate is just another opportunity, not only to save time, but really drive collaboration efficiency into the process. I think that's really important. And it's just kind of I guess, a fun thought to leave you with. Um, when you look at the decarbonization journey, I don't know, you may have seen this, Dale, but that there's a documentary called Beyond Zero about
Yeah.
Ray Anderson and his journey with his carpet company to decarbonization. And I just found that really fascinating in how that company took a aggressive and collaborative approach and succeeded in what they wanted to do. And if any of the podcast listeners haven't seen Beyond Zero, I would check that out and encourage you because it'll, I think, really motivate you to look not only to decarbonization as the right thing to do, but something that will really drive profitability and efficiency.
Yeah, that's a great recommendation. Totally agree. And to your point around collaboration as well, we always achieve more when we can collaborate together, and it is going to be a joint effort across multiple agencies and companies. And the good news is we're seeing it, right? People are doing it, and they're in the middle of all this innovation, and we want to be a part of that and help us decarbonize overall. So, David, once again, thanks so much for taking the time. I know you're a busy person, so definitely appreciate that. And we'll see you next time on the Applied Imperative podcast.
Really enjoyed the conversation, Dale. Thanks for having me.
Thank you so much.